Back, guys. Now, in the last video, we stopped at the control plane security group configuration and the worker node, all right, security group configuration. So we've done all of the necessary things as it relates to configuring, all right, the security group, and of course, all of the ports that we need to configure. We have put all of that in place. Now, the next thing we need to do is to install what you call the container runtime interface, CRI. All right, that is the next thing that we need to install. Okay, we need to install what? The container runtime, all right, interface. Now here, don't forget we're using Kubernetes 1.30 version. So if you want to change your version, you can just click here and then select the version that you want to use. So in our case, we're using 1.30, all right, Kubernetes version. Okay. Now, here we need to install a container runtime, right? I mean, you need to install what you call a CIR, right? So as it says here, an API for container runtimes to integrate with Kubelet, okay? So, and of course, we have quite a number of container runtime that Kubernetes can use, right? I mean, it's an open source application, so it has different open source, container runtime interface that you can actually leverage, okay? Now, there's Containerd, there's Clio, there's Docker Engine, there's Mirantis container runtime, but in the course of this, all right, session, we're going to be using the Containerd, all right, runtime, which actually is also, the container runtime that Docker actually also uses. Okay, so whether you're using Docker Engine or you're using the Containerd, it really doesn't matter. What matters is that you're using, all right, a container runtime interface supported by Kubernetes. All right, and that is why you have all of these things listed out for you. So if you want to use any one of them, you can basically just click on any of them, and then it will take you to their documentation page, and then you can follow, all right, whichever one you want to use. But in our own case, we are going to be using the Containerd, all right, container runtime interface, CRI, all right? Now, how do we use this container runtime interface? Now, following the documentation, we have some prerequisites here before we even install, all right, the container runtime, right? There are things that we need, all right, to make sure that we do on our system. Now, it says here, it says by default, the Linux kernel does not allow IPv4 packets to be routed between interfaces by default. So we need to change that, right? We need to change that behavior. So the first thing we need to do is basically to run this particular command here, all right, on our systems. I mean, all the three systems that we have, the control plane and the two worker nodes, okay? And then we can use this to basically verify that. Now, once you have done that, you can now go ahead and configure, all right, your container runtime. Basically, you can click on any of these ones, and then it will direct you basically to the page. And then you can see here how you can actually install, all right, the container runtime on your system, basically, right? So you can see how to configure it and all of that, right? But before we go there, we need to, of course, do this particular thing first. But what I have done in the course of this section is that I've put everything together for us in a shell script. All right, so both the container runtime and this configuration that you can see on the screen packaged everything together, all right, as a shell script that we can execute on all our instances, right, without doing them one by one. Okay, so let me take you, all right, to the shell script and let's see what it looks like. So here I have the shell script here, and by the way, all of these things that you see here is available in my GitHub repository, and that link is of course in the video description, so you can get the link from there, and of course do all of these things that I'm doing right here. So let me walk us through all of this. Now, this is basically what we saw now, right, that we can do to just basically open up the interfaces, right? So if here it says to us that we need to enable IPv4 packet forwarding, right? So all of this command that you see here, I basically put that in a shell script, right? And then everything right here. Now, the next thing we have to do is to do sudo apt update on our machine, since we're using, all right, Ubuntu. So we need to update our package managers before we can go ahead and install a container runtime interface. Now, after that is done, we can just do sudo apt-get -y install containerd, and that will install, all right, containerd on all our systems, right? Now, once your containerd has been installed, you need to create a folder called, all right, /etc containerd, because I mean, by default, this folder is actually, all right, not present, because you need to create a configuration file for your containerd. Right, and the configuration file name is config.toml, right? And then you need to do some kind of, bootstrapping of that configuration file, which means you need to do something like this, which is container D config default, all right, and then you pass whatever it is that you have generated on the left, all right, to this configuration file that you have on the right using the T, all right, command. Now, what the T command actually does is that it takes the standard input stream, all right, from the left command here, and then it basically writes that, all right, into the standard output stream and into a file system. So this is the file stream. So whatever this standard input stream generates, all right, by the help of this pipe symbol, the T command is going to take that and of course, and write that into this particular file. Okay. And then we need to do that. Now, the next thing we need to do based on the documentation is to actually configure what you call, all right, the systemd, all right, group driver. So if you scroll down a bit, all right, you should find something here. All right, so here it's telling us that we have to configure the systemd C group driver, and this particular thing, systemd C group, has to be true, because by default, when you bootstrap with the default container D configuration that you see here, all right, that systemd configuration is actually false, and so we need to change that, all right, to true. Okay, and that is what this particular command is going to do for us. So this particular sed command is basically used for substitution, right, which basically stands for standard stream editor. So we can use that to substitute something. So here, what we are saying here basically is that it is going to read, all right, so we're going to use that to read this particular file, and then inside of this file, we're basically using that command to say that if you look at the file, kindly look for a line that says this, and then change the value from false, all right, to what? To true. Okay, so this sed command is basically going to do what? Read this file, and then it's going to look for this particular line, and then it's going to look for this particular section that says equals to false, and it's going to replace that with what? With true. And then once that is done, we basically just do what? A system restart. I mean, that makes things a lot easier. So I'm going to copy all of this, and then I'm going to go to my instances, starting with the control plane. And here, I'm just going to say here, vi container, all right, d.sh, right? And then I'm going to paste everything right here, all right? And then make sure you save that, all right? And of course, you have to make it executable. So chmod plus x, and then you say container, all right, .sh, right? And then if you look at what you have here, it is now executable. So what do? We say slash, and then we execute it. So let's see what this will do for us. Now, everything, as you can see here, is actually running. If I scroll up a bit, I'll see that the first command actually worked already. So it applied all of that, IPv4, whatever stuff. Okay. And then now it is installing the container D, and of course, it's going to do everything that was specified for it to actually do, all right, for us. So let's just wait and let this happen. Now, while we're waiting for this, we don't need to waste time to watch this happen, all right? So we can come here again, copy this, go to the other nodes, and basically just do the same thing, right? So vi container D, all right, container D.sh, and then paste that here, okay? And then you save that, all right? So make it executable, chmod plus x, and then container D, sorry. All right, and then execute that right away. So that is also doing its own thing. So let's go to worker B. So vi, okay, container D.sh. All right, so let's paste that also here. All right, and then we save that. So chmod plus x container D, and then we run the same thing, all right, as well. So now the control plane should have completed, but of course I think it's still running. So let's wait and see that. All right, okay, so that's completed already, okay? So everything is done as we expect. So I mean, what was the last command we ran? So the last command we ran was to restart, all right, the container D service, all right, as well. So now if you look at all this configuration, if you scroll up a bit, and then look for the place that says, now look at it here. So this systemd C group by default is what? It is false, right? But here we have specified that this sed command should actually change that, all right, for us. So we can actually just, view it and see if it actually happened, or maybe the command ran successfully or they didn't run successfully. We can actually verify that. So we can copy this, okay? And then we can just do sudo, all right, cat, and then put that command here, and then we can just basically just say grep So we want to grep what? We want to grep the line that basically mentions system C group. I mean, we don't have time to look at all the configurations. So we can just use grep, all right, to just basically say, this is the line that I'm actually interested in, right? So we press enter. Now, if you look at it here, it has turned to what? It has turned to true. So that means this sed command that we mentioned here actually did what we intend for it to achieve. Okay, so now this is set to true, and we can actually do the same thing for other systems, just to be sure. We can go here, that is also completed. We can take a look at that, and of course, this has been changed to what? To true as well. And then we can come here as well and put that here, and this is what? Changed to true as well. So that means that configuration actually worked as we hoped, that it will work. Now that's a good one there. Now containerd has been installed for us. So I mean, if I do sudo system, sudo system ctl, status containerd, I mean, I can see that my containerd is active and is running. Okay, so I can do that across all my nodes. I can go to the control plane and do the same thing. So sudo system ctl, status containerd. I can see that my containerd is running. And of course, for the avoidance of doubt, let's do it on the other node as well. So sudo system ctl status, containerd. Okay, we can see that the containerd is up and running. So let's clear the screen here. Of course, we've done all of the things. Oops, sorry. So clear your screen, and then here also, let me clear my screen as well. All right. So now we have the containerd installed. We have the containerd installed. The containerd is running. And of course, everything is working as we expect. For it to actually work. Now, what is the next thing that we need to do? Now, the next thing we need to do now is to basically install, the Kubeadm, We need to install the Kubeadm. Now, we're not going to install the Kubeadm alone because, I mean, that is not the only tool that we need, actually, In addition to the Kubeadm, we need a Kubelet, and we also need what you call Kubectl as well, We need Kubelet, we need Kubeadm, and we need Kubectl, Now, Kubeadm, basically, so let's understand what each of these things do, will do for us. Now, the Kubeadm, this Kubeadm that you see right here on the screen, it is basically responsible for initializing the cluster, It is the command that will help us to create a control plane and do all of that, that we need to do, for us, The kubelet, does things like starting the ports and the container, and then the component that basically runs on all the machines in the cluster. That's what the kubelet, will do for us. Now, the Kubectl is a command line tool, that helps us to talk, to the cluster, which means when you want to access your cluster, you basically use the Kubectl command, to achieve, that particular purpose. Okay, so we need those three, Kubernetes tool, to be installed. So Kubeadm, Kubectl, and Kubelet, we need those three tools, in order for us to, start, our cluster basically. So if you scroll down here, of course, we've done the container runtime installation already. And then here it says installing Kubeadm, Kubelet, and Kubectl, And it says we will install these packages on all your machines. Take note of that. These packages are what will be installed on all the machines, So you cannot just install one and then leave the other. So Kubeadm, Kubelet, and Kubectl will have to be installed on all machines. So you can see the description here as well. I've mentioned this already, And it says here, Kubeadm will not install or manage Kubelet or Kubectl for you. And it says, so you will need to ensure that they match the version of the Kubernetes control plane. So what that means is that if your control plane version is 1.30, then your Kubelet, your Kubectl, and your Kubeadm should also, be 1.30. So basically, what this means is that these three, packages must be of the same version, Your Kubeadm cannot be 1. Your Kubeadm, for example, cannot be 1.30, and then your Kubelet is 1.29, and your Kubectl maybe is 1.30 again, I mean, there's going to be conflict, So they have to all be the same version. So if you're using 1.30, they all have to be what? 1.30. If you're using 1.29, they all have to be 1.29. Is that all right? Now let's take note of that as well. All right. Now, so let's see how we can install all of these things, that we have here. Now, again, I've been able to prepare us or a shell script that can help us to install all of these components all at once, right? I mean, if you go to the documentation page, you actually can see that here. So if you scroll down, all right, we're dealing with a Debian-based distribution. So that means we're going to go with this one. We're not using a Red Hat, all right, distribution. So we're using a Debian-based. I mean, we're using Ubuntu. And it says here, this instruction are for Kubernetes 1.30. So which means if you're using a version that is 1.29 or 1.31, then you have to come here to versions and then change your version to that to get the correct installation, all right, instruction. Okay? So here, all of these things, we need to execute them. So apt get update, apt install, and all of that, right? Now, already, I have done all of that for us, right? I mean, I've done all of these things for us here. So if you look at what you have here in the shell script, you have everything configured already. Apt update, apt install, all right? Here, we're specifying, here, take note, we're specifying 1.30, right? 1.30, okay? Because, I mean, by default, Kubernetes is not, or sorry, by default, the Kubeadm, the Kubectl, the Kubelet, right, is not available in the apt repository by default. So we have to add, all right, these things to the apt repository in order to make it available, right? So that is what we're doing all of this call, and then we're doing all this echo, basically to add it, all right, to the apt repository on our system, so that by the time we do apt get install Kubelet, Kubeadm, and all of that, it basically will just have to download, you know, everything from the repository, all right, that was specified, which is this one right here. Okay, so here I put everything into a shell script. So we're specifically installing version 1.30. Now 1.31 is the newest version, but of course it is safe to just basically, you know, install a version that is maybe, all right, how do I put it now? All right, one version below the latest version, right? So 1.30 is more like the, you know, the more recent version, and then you have the 1.31, which is the latest version. Okay, so that is what we're using, 1.30. All right, I mean, tomorrow you can upgrade later, all right, to 1.31 at a later time. Okay, so all of these things have been put into a shell script for us already. So I'm just going to basically copy this, all right, and go back, all right, to my control plane. I'm going to start with that, and then say vi, and then I'm just going to say k8 component, all right, .sh, right, and then I'm going to just basically paste everything right here, all right, just like what we did, in the last, all right, session. So chmod plus x, sorry, plus x, and then k8 component. I mean, I can just run that right immediately. Okay, so let's run that and let's see what I will do. So that is working already. So let's do the same thing here. I mean, we saw it already there that it tells you that these things must be run on all of the instances, right? So k8 component. I mean, is it component or component? Let me just quickly check that. So that is component, right? Okay, so great. So k8 components. All right. So I paste all of that in there. I mean, just use save. I mean, I didn't put the sh, so I can just say mv, all right, k8 component to k8, or a component.sh, right? So I'm basically just renaming that, right? So that's fine. So ch mod, all right, plus x, and then k8 component.sh, and then now let's run that also, right? So that is running. So let's come back here also, vi k8, all right, components .sh, and then paste all of that right here, and then save that chmod plus x k8 component, and then execute what you have to execute and all of that. So now on the control plane, all right, the kubelet says set on old, Kubeadm says set on old, Kubectl says set on old. Now what does that mean? If you look at this particular command, which is apt marker old kubelet, all right, and all of these, it basically means that this apt mark old will basically prevent the package from being automatically upgraded or removed. So that means we basically, you know, set that version, right? The version cannot be, we can overwrite it, right? It is basically just locked down, all right, to that particular version. Okay, so that will prevent, okay, the component from basically just, you know, from basically being updated or just, you know, arbitrarily, you know, removing it and all of that, right? So that is basically what the apt-mark old would do for us, basically. So we have all of this set on old, which means the version is fixed and nothing can actually change that. So this is the same thing here that we can see, all right, and everything is right here. Now that we have done this, so what is the next thing for us to do, right? what's the next thing we need to do? So here we can say kubectl. All right, I mean, if we do kubectl like version or something, so let's check that. Right now that is invalid, so let's do double hyphen right there. Okay, so it's not seeing it, so basically it might just be kubectl version. All right, and then you can see it here. Now here it says the connection to the server localhost was refused. Did you specify the right host or the port? I mean, we're going to fix that later on, right? But then we can see that the client version is what? 1.30.0, right? I mean, you can do the same thing for Kubelet, all right, Kubelet, okay? And then you can say version, I guess that should work. All right, so that worked. And then, of course, you can do the same thing for Kubeadm, all right? And then you can say version, all right? Okay, so that flag is not working with this one also. So let's just try version instead. Okay, so you can see the version as well and says this is what? 1.3 or 0. So they basically are using the same, all right, version, okay? So now I can clear my screen and I can do sudo systemctl s2 status, all right, kubelet, right? And now you can see something here. So here it says it is what? Your kubelet is what? It is inactive. Okay, kubelet is what? Is inactive. Meaning, now the purpose of the kubelet is actually to create the ports, the static ports, right? All of those components that we saw earlier in the documentation page, right? All these, all these, what do you call it now? All these, Kube API server, etcd, Kube scheduler, Kube control manager. It is the job of the kubelet to actually create, all right, all of these components. But right now, it is saying what? It is inactive because by default, when you install all of these things, what the kubelet does is that it monitors a directory called /etc, all right, Kubernetes, all right, Kubernetes, all right, /manifests, all right. Now, it monitors this particular location, right, to see, because now we've not initialized the cluster. Right? We've not done that already. Now, by the time we do Kubeadm init, right? Now, Kubeadm init is going to create, all right, a certain number of directories, right? Because, I mean, what happens within Kubernetes is that all of your components, they have to communicate together using a secure kind of communication. Okay, so which means that Kubernetes, basically, by the time you do Kubeadm init, all right, your Kubeadm is going to generate what you call self-signed certificates that will allow all of these components, right? Your etcd, your Kube API server, your controller manager, your scheduler, that will allow all of these components to be able to communicate together. Because within a Kubernetes cluster, every component has to communicate securely, all right, using a certificate. Right? Every component in Kubernetes, every component in Kubernetes has to communicate using a self-signed certificate, all right, which allows their communication to be what? To be secured, right? So which means you can say that in Kubernetes, there is no unsafe communication, right? Because communication from one component to the other actually requires, all right, some kind of TLS certificates to be configured, all right? So which means when the Kube API server is trying to talk to, all right, the scheduler or the kubelet, all right, that communication is actually encrypted, right? It is not something that can be intercepted, all right, and interpreted by anyone, basically, right? Just, technically, okay? So now we need to initialize, all right, our cluster, okay? And how do we do that? Basically, we use the command kubeadm init, all right, to initialize, all right, the cluster. And that command is only going to be executed on the control plane. Okay? That will be what? Will be executed only on the control plane. So when you scroll down a bit here, all right, the next thing here says using Kubeadm to create, all right, a cluster. So if you click here, all right, if you click on this instruction, now that will take you to what you need to do, right? So it takes us back to that particular page. And then here, if you scroll a bit down, right, you can see some of the commands that you need to run, right? You have the Kubeadm init, all right? This step is optional and it only applies in case you wish Kubeadm init and Kubeadm join and all of that. So Kubeadm init is what we actually need to initialize, all right, the cluster. So that's the command right here. So Kubeadm init. And of course, if you look at the commands that I have here also, that actually has been provisioned. So sudo kubeadm, all right, init. So that is the command that we need, all right, to execute right now on the control plane, right? On the control plane, that is where we need to initialize, all right, that particular thing. So let's run that and let's see what happens this time around. So let's execute that now. All right, so let's take a look at what we have here. So now it says there's a remote version. Of course, it's telling us that there's a newer version, which is 1.31.0. I mean, that's the newer version. But of course, we're using the Kubernetes version 1.30.4. And then it is running some pre-flight checks. All right, so that's the first thing it will do, running some pre-flight checks. So the pre-flight check is basically to check, if all the necessary ports are opened, if all the things that it needs to perform that initialization is actually available, all right, to it. All right, that is basically what the pre-flight check is about. So just basically trying to say, well, let's do some, some checking, all right, to see that, all the container runtime and every other thing that is necessary, all right, every other thing that is necessary is actually available, and then we can go ahead and start generating stuff. So here you can see that they started with generating the certificates, right, that is needed. So you can see here it's generating certificates, all right, and then here you can see that some kubeconfig are being created, and then you can see here that some directory are also being created automatically by Kubeadm, all right, and then it is also trying to initialize the control plane, all right, as well. And then it's creating some static pod manifest, right? So you can see, so inside of this particular directory, which you have the etc Kubernetes manifest that I showed us earlier, it is creating some static pod manifest. So there's a kube API server, there's the kube controller manager, and then there's the kube scheduler, right? So it's trying to create, all right, all of that. All right, so it's trying to create all of these things, and then the kubelet will actually monitor this particular directory, and then the kubelet is responsible, all right, for using the manifest created by Kubeadm to basically create all of these components that you see, all right, right here. Okay, so here it's saying what? Waiting for a healthy what? Kubelet. Can you see that? Waiting for what? A healthy kubelet. So all of these manifest files have been created, and then now it is the turn of the kubelet to basically check that those manifest files are present, and then it is the responsibility of the kubelet to basically now use those manifest files to create, all right, all of those, all right, components that we need, right? The kube API server, the kube control manager, the kube scheduler, and all of that. So you can see here that, of course, everything is going on as expected. And if you scroll right here, you have this command, kubeadm join. All right, this is basically how to join our cluster, all right, to our worker nodes, rather, all right, to the cluster. So this is the command that we're going to use to join the worker nodes, all right, to the cluster. But before we do that, I mean, it says you should now deploy a pod network to the cluster. So the next thing we need to do now is to basically configure our cluster network interface. I mean, we've done the CRI, which is the container runtime interface, but now we need to deploy what you call the container network interface, which is the CNI, all right, that will allow this communication, all right, to take place. Now here it says to start using your cluster, you need to run the following as a regular user. And now it's giving us some commands to do that, right? So basically we have to make a directory. Of course, the directory is .kube. And then here we can copy whatever it is that we have in this admin.conf. So the admin.conf, it's more like your kubeconfig, right? Your configuration file that contains some information that I think is necessary. So let's just copy this path. Let's see what actually is inside of that, folder. So I'm going to say sudo cat. All right, I'm going to drop it here. And then let's take a look at what we have right there. Now look at what you have here. Now here you have your API version 1, and then it says cluster, and then look at it here. So it generated a cluster certificate for us. So this is self-signed certificate, and that tells you that even to connect to your Kubernetes cluster, you need, all right, to have a certificate in order to use a kubectl, all right, to connect to your cluster, right? I mean, that is of utmost importance in Kubernetes, right? So you have that. And then you have some context here. You have the default Kubernetes username, which is Kubernetes admin. That's more like the default already user. And then even for the user, you also have another client certificate that the user will have to use in order to authenticate with this, all right, cluster. All right, you can see all of that here. So that tells you that, communication within the Kubernetes component is actually a very secured, all right, communication, right? So, I mean, for what we can see now, we can see that, I mean, everything actually is about, certificates and all of that, right? So, and if you follow all of this configuration, you can see that some tokens were generated to actually help us to bootstrap. And then you can see all of this information right here. And also we can actually go into this manifest file to also see, all right, all the manifest that was actually created. So I'm going to say sudo ls, all right, and then I can paste that path here and then see everything right here. So here, if you look at it here, you have the HCD, the YAML, you have the Kube API server, the YAML, you have the Kube controller manager, the YAML, and you have what? The Kube scheduler, all right, the YAML, right? So this manifest file, all right, these are the things that Kubelet rather actually used to provision, all right, all of the components, all right, for us. So the etcd component, the Kube API server component, the Kube controller manager component, and the Kube scheduler component, right? These are the files that your Kubelet actually used to provision, all right, all of these components. Now, in the next video, we're going to just explore this component and then move forward to see how to set up, all right, our container network interface to actually allow us to join the worker nodes to, all right, the control plane. That's the next thing we're going to see, all right, in the next video. Thank you for sticking around, and I'll see you on the next one.